In this lesson, we are going to be graphing linear functions again, just like you just got done doing, except this time we're not dealing with individual transformations, we are dealing with multiple transformations. AKA, instead of moving the linear function up or down, or instead of changing the slope around, we're going to do both at the same time. All right, these are problems that we have seen already on the previous lesson. Now, before I describe them, I am first going to graph the parent function y equals x, which looks like this, roughly. What we are going to be focusing on is this center dot right in the middle, 0, 0. I want to know how that's going to be moved around. So when I graph the red function, it is actually going to be moved right here. It's difficult to see with linear functions, but as we move forward, it'll make a little bit more sense with the more advanced functions. And it'll look like this. So the way I would describe that transformation is it literally looks like the parent function if I moved it right 3. So when the parentheses are here, a minus 3 inside of it is going to move it right 3. Now I know a lot of you looked at that and said like, whoa, doesn't that move it down 3? Doesn't that actually move the dot here? This is the problem with linear functions, is technically, yes, you are also correct. This is also just moved down 3. It just depends on how you want to perceive the function. I am advising you, though, to help you with future lessons in this chapter, if there are parentheses present, I highly recommend that you look at it as moving left or right. It'll help you in subsequent lessons we're going to do in the following sections. So for problem number 2 in blue, I have a y plus 4. Well, if the minus 3 moved me right 3, it makes sense that the plus 4 would move me left 1, 2, 3, 4. And then it would follow the same trend. So plus 4 in the parentheses makes me move left 4 units. Now I'm dealing with no parentheses. It's just y equals x plus 5. This is where you can visualize it moving up and down. So for a plus 5, that will move the center up to here. It will move it up 5 units. And the graph will look something akin to this. And then finally, y minus 8, I think we could all figure that out, is going to move us right down to here. That is going to move us down 8. So this is how you can transform a linear graph up, down, left, or right. The next section is where we start changing the slant of use that vocabulary. What happens if we start multiplying by numbers? So again, I'm going to graph the parent function. This is just y equals x. Nothing special, just y equals x. Not adding anything, not subtracting, no parentheses, just a straight vanilla function. As soon as we have a multiplication of 2, which you could visualize as having a slope of 2 over 1, that's fine, is that would create the following function. So how does that change the graph? Well, if you analyzed all of the coordinate dots on the parent function, you might notice a connection between those coordinates and the new ones in red. The coordinate here has a height of 1. The coordinate here has a height of 2. That is 2 times the height. The coordinate here has a height of 3. The coordinate above it has a height of 6. It is 2 times the height. We are doubling the heights. The vocabulary that we use for that is not the slope is 2, because the slope is 2, while it is true for linear functions, we're trying to establish vocabulary that's going to be true for all functions. And the vocabulary we use is it is stretched vertically by 2. If you imagine the black line as almost like a JPEG, an image, a digital file that you just have and you can edit, you can stretch it diagonally, vertically, horizontally. That red line is that black line as a JPEG if you stretched it just in the vertical direction and you made it twice as tall. If you took the black line and stretched it to be twice as tall vertically, you'd have the red line. Problem number 2, I have y equals negative 3 times x. Now the negative and the 3 do separate things. We already know what the 3 is going to do. It's going to stretch vertically by 3. So the blue line, I already know because it's multiplied by 3, I already know it's going to be 3 times as tall as the black line. But the negative does something else. The negative is a second type of transformation. What it's going to do is it's going to take the image and it is going to flip it vertically. It's going to invert it. It's going to make it be upside down. But I would like you to use the vocabulary flipped vertically. The reason why I want you to use the vocabulary flipped vertically is because if you just say flipped, you can have an image and flip it horizontally. You can flip it vertically. You could flip it diagonally. Saying the word flipped is not enough. That's the equivalent of giving someone directions to your house and saying, yeah, on this such and such a street, turn. You have to give them a direction as well as an action. So saying that the function is flipped, that's telling you the action, it's not telling you the direction. We don't want to say upside down or reflected over the x-axis because depending upon when you take that step, it can technically be wrong. So we are instead going up and to the right. We're going to be going down and to the left. So all the heights are going to be flipped and it's going to be tripled. So it's going to go here, 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 here. Because I took all of the black heights, like this one right here. This has a height of 2. I am going to triple it and then flip it. If I triple 2, I would get 6. But instead of going up 6, I'm going to go down 6. Again, realize this is also just the slope. Down 3, left 1. Down 3, right 1. Down 3, right 1. This is the graph of the linear function. Oops, I went over one too many. And then finally, the green function. Kind of weird. I wanted to throw a challenging one on here. 4 over 5 is a number that is actually smaller than 1. So we're actually not going to stretch this function. We're not making it bigger. We're actually making it smaller. The vocabulary we use is not stretching anymore because we're not stretching it. We're not making it bigger. We are compressing it. Compressed vertically by 4 over 5. And then because there's a negative, it is also going to be flipped vertically. So it still starts at 0, 0. We can act like this is the slope, because it is. Negative 4 over 5 is down 4, right 2, 3, 4, right 5. Down 1, 2, 3, 4, right 1, 2, 3, 4, 5. Up 1, 2, 3, 4, left 1, 2, 3, 4, 5. Up 1, 2, 3, 4, left 1, 2, 3, 4, 5. It's going to look like this. So my green line is just the black line. If you made it 4/5 the height and you flipped it vertically, you would get the green line. So everything I've done over the last 2 slides, those are a review and recap of individual transformations. What we are doing in this lesson is a little bit more than this. We are going to be doing all of the transformations in a single problem. So notice that these questions have multiple parts, but we have already done every single one of those parts before. I already know what a -3 does inside of the parentheses. That's what moves me left and right. So a -3, if you recall from when I was doing it earlier on slide 2, that is going to move me right 3. The number at the very, very end, that dictates how I move up and down. So I'm going to go up 5. And then lastly, the 1/2 either deals with stretching or compressing. So I'm either going to stretch or I am going to compress. Because it's a 1/2, smaller than 1, if I take the heights and multiply them by 1/2, I'm getting smaller, not bigger. If you multiply something by 1/2, you're getting half of it. That means we're not stretching, we are compressing in the vertical direction. Since I know these transformations, I don't need to make a t-table anymore. I can just go from the equation straight to the graph. I'm going to go right 3 and up 5. 1, 2, 3, 1, 2, 3, 4, 5. This is where that center line is. I already know what the slope of this function is. It's +1 over +2. That tells me to go up 1 and right 2. Up 1, right 2, up 1, right 2, up 1, right 2. I could also go down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. There's the graph of the red line, and I never even thought of a t-table because I just recognized the transformations of the function. But I'll do another one. The blue function. I have y equals -4 times the quantity of x plus 6. I already know what the plus 6 inside the parentheses is going to do. That's going to move me left 6. Now, there is no number being added or subtracted on the outside of the parentheses like there was in number 1. So that means in terms of movement up and down, I'm not going to move up, I'm not going to move down. I don't need to say that either. I don't need to say up 0. But the 4 is my stretch or compression number. That number is bigger than 1, so this is going to be stretched vertically by 4. So this is going to be 4 times taller than the original function y equals x. And then lastly, I have that negative. That negative always is the same thing. It just flips it vertically. All right, now that I've got my verbal description, I can graph this. I'm going to go left 6. 1, 2, 3, 4, 5, 6. Here's left 6 right there. My slope is -4, which is just -4 over 1. So that dictates to me I'm going to go down 4, right 1. 1, 2, 3, 4, right 1. Down 1, 2, 3, 4, right 1. We could also go up 1, 2, 3, 4, and left 1. Up 1, 2, 3, 4, and left 1. I now have a bunch of dots, so I could graph my line. And lo and behold, that blue line compared to the original black line, the y equals x line, it is that black line. If we moved it left 6, we made it 4 times taller, and we flipped it vertically. You did that, you get the blue line. And then finally, I have the green problem. It looks more challenging because of the fraction. It's not. The plus 2 inside the parentheses tells me to move left 2. Oops. The minus 1 on the very, very outside of the parentheses tells me to move down 1. The number on the outside of the parentheses being multiplied, that's 7 over 9. Well, 7 over 9 is smaller than 1, so I'm not stretching it. I'm multiplying by something smaller than 1, so I'm making it smaller. That is going to be compressed vertically by 7 over 9. So now I have that verbal description. Now I can graph it. I'm going to go left 2 and down 1, which is right here. And then the slope is positive 7 over 9. So from that dot, I'm going to go up 1, 2, 3, 4, 5, 6, 7, and right 1, 2, 3, 4, 5, 6, 7, 8, 9. Because that slope is so outlandishly large, we don't really have a whole lot of room to make another dot. Actually, we do. We could go down 1, 2, 3, 4, 5, 6, 7, and left 1, 2, 3, 4, 5, 6, 7, 8. Nope, never mind. We don't have enough space. Almost had enough space. But there's the green function.